All right, well, thanks to Rolf. It's nice to present this work to this group in particular because I think it builds on a lot of the themes we've been talking about for the last 2 days. And in terms of modeling pedestrians, it's a task I've been working on now for about 12 years, partnering with Bob Schneider at the University of Wisconsin-Milwaukee. And my first attempt at this was for Maryland DOT, who had an interest in modeling pedestrian demand so that they had the denominator for their risk exposure for crash and safety analysis. And I'll just say that that effort was perhaps a disappointment to them, but I learned a great deal that's gone into this iteration of work that I've been doing for Portland Metro. So, part of the impetus for this work is that pedestrians are poorly represented in our travel demand models, whether we're talking about integrated models or we're just talking about regional or urban models. So in the United States, only about a third, a little more, a third of them estimate walking as a mode in their mode choice. And another third of them lump non-motorized modes together. So it's a bit of a pet peeve because those modes, I think, have very different travel characteristics and travel speeds. And about 40% don't have walking at all, so it's a problem. And then despite the fact that we've made great progress in having spatially or archived spatial data at a resolution to deal with this problem, again, most of these models don't have adequate measures that are sensitive to the pedestrian environment. So why would we want to model these in an urban model? First of all, just thinking about pedestrian investments. So whether that makes sense or not at a regional model scale, I'm not sure, but that's one alternative. I think the larger reason is to detect mode shifts that happen due to some of these larger land use changes. So in the case of Metro, that was their interest here. The state has some climate change legislation that's mandating that Metro come up with 2 different scenarios that shows that they can meet the climate demands. And if they can't show that people are shifting to walking, they have a problem. So that feeds into the greenhouse gas emissions question. Increasingly, people are interested in the health outcomes and doing health impact analysis. And again, Oregon is interested in linking health impacts to its statewide model. And then for crash safety, again, thinking about risk exposures. Thinking about transit accessibility, willingness to walk, and what those travel sheds would be or access sheds would be from transit is an important question. And then from my specific interest as a travel behavior researcher, just understanding what the new research opportunities would be from these modeling efforts. So I've been having a conversation with Rolf about this in terms of thinking about integrated models. And so while this is not, say, far from an easy task, I think we're much more prepared to think about the suite of travel decisions in the travel model, at least trip generation, destination choice, and mode choice. And then in terms of presenting more challenges, but maybe on a second tier, route choice questions, there's been a fair amount of work on pedestrian route choice, I think, by some of you in this room. And then thinking about how then you translate that into some travel cost measures that could feed back into the suite of travel decisions, and then how that affects at least local accessibility and whether it affects or it's a consideration at all in terms of residential location. So there it's probably more into those lifestyle, attitudinal aspirations. What are you looking for out of your neighborhood? And again, there's some work there, but not quite ready for prime time in terms of integrating it into a model. And then considerations for car ownership as well. So if you can walk instead of drive or take transit, then what does that mean for the number of vehicles that you own? And then I think the most challenging is thinking about assignment, whether assignment is a necessary task. And at least for my first effort in trying to assign pedestrians to the network, I'll say that I just shied away from it ever since, so I haven't really looked at it in 9 years, but I think it's the more challenging of these tasks for integration. So what I'm going to talk about today, I'm missing one there, is just my efforts in Portland to think about the travel model itself. And so how do we think about integrating pedestrians into the regional urban model that we have? So I'm not going to go through all the gory details. I'm going to spend some time talking about what we have learned or things we're thinking about, both in terms of research and in terms of practice and model structure. But basically, when Metro approached us for this problem, they wanted limited amount of modification to their current model structure. So they didn't want to have to re-estimate. They really didn't want to have to change their zonal structure. So they presented us with that challenge of how can we integrate, how can we have a model that's sensitive to the built environment, but operates at a scale where we can really detect these differences. So the model we're calling Model of Pedestrian Demand, or MOPED, and we've presented a new spatial scale or spatial unit called the Pedestrian Analysis Zone, or PAZ. And so what we do here is we conduct trip generation at this PAZ level, and then we skim off, if you will, the walk trips from the vehicular trips. And then we hand back those vehicular trips back to Metro. They aggregate them up to their zonal structure and run those through the rest of their model. And so at that point, they've lost interest in anything that we would do after that. Intellectually, they're interested, but practically and monetarily, they're less interested in what I do with those afterwards. And so we did a second phase of this work where we went on to look at destination choices for pedestrians and retaining the PAZ scale for that work. Okay, so some of the contributions, so it nests within the current zonal structure, so Metro can use it, but I think it also allows it to be used as a standalone tool, so you don't have to run it at the whole regional scale. You can do corridors or sub-regional scale, and you have a nice tool to think about pedestrian demand. We do change the scale, and we've developed a pedestrian index of the environment, or PI, so one of the many built environment measures that have come out of pedestrian modeling in general, or pedestrian travel behavior in general. As far as I know, this is the first attempt to look at destination choice within a demand modeling framework and try to model it at that very finite scale. And then we highlight the policy relevant variables that Metro will be working with in terms of trying to conduct these scenarios to see, what are the policy variables that we might see some shifts. So travel distance, density, and then pedestrian supports and barriers in terms of infrastructure. So our PAZ is about 80 meter by 80 meter grid cell level. It represents about a 1 minute walk time in Portland, and it just happens to coincide with the block size of central Portland or downtown Portland, which has the smallest block structure in the United States. But what that means from a practical standpoint is you go from about 2,000 TAZs to about 1.5 million PAZs across the region. So that's not an insignificant amount of complexity you're adding to the model. But you can see here the comparison between TAZs and PAZs in terms of what this starts to look like. We actually didn't choose this scale, so Metro already has a lot of fine-grained data using this grid cell structure, so we went with it. So I think there's a question about whether it's 80 meter by 80 meter or 150 by 150 meter grid cell level. It's a question for both what data are available and what we learn from travel behavior in terms of sensitivities. So the first thing we did was look at what are the environmental variables we wanted to include in our index. And so we looked at 6, so based on what the travel literature told us and then what we had available at that grid cell level. So an activity density, an access to transit measure, a measure called urban living infrastructure, which is Metro developed this measure, which is effectively retail and services that support daily life, so grocery stores, barbershops, banks, bars and restaurants, and so on. The average block size, the extent of the sidewalk coverage, and then whether or not there are comfortable cycling facilities. So that really doesn't have anything to do with walking directly, but we do have a number of facilities where you have bike facilities there and further separates the pedestrian from the roadway. And so if it is a comfortable place to ride a bike, then we are hypothesizing that it's probably also a comfortable place to walk. So in each of these measures, we did a univariate logit model predicting whether or not a trip would, or its relationship to walking, and then use those standardized coefficients then in an index which we summed and then scaled to Portland. There's some problems with it. It works fine from Portland for now, but the work that I'm doing now is really thinking about how to evaluate this, one, where the top of the scale isn't Portland, and second of all, using data that other cities might have in more commonly available. So this is what our pedestrian index of the environment looks like if you know Portland. So you can see central Portland is at the top, and then the distribution of pi across the various nodes and suburbs. Okay, so we use pi then at several stages, so in the walk mode split and the destination choice module. In trip generation, we basically just applied Metro's trip generation models, their existing models, to that PAZ scale. So we had to do some testing to make sure that they were scalable. The other issue is whether or not we had all the inputs at that PAZ level. So we had 8 trip production models and just applied them to our 105 million PAZs. And so the model outputs, so the top left is what Metro's output is at the TAZ scale, and the bottom right is our output at the PAZ scale, and when you aggregate ours up, they match. So we felt good about that and moved on to the next task, which is skimming off then the walk mode share. So again, another binomial logit model, looking at whether or not the propensity to walk. And so here, the model was estimated as a function of travel characteristics, and then our measure pi of the built environment. I'm not going to go through all the model results, but we did this for 3 trip types, or trip purposes. And again, the traveler characteristics were household size, income, age, number of workers, number of children, and number of vehicles. So basically the data that we had as inputs, and then the built environment pi. And so after you apply the model, you get, this is just a sub area, but you get a distribution of trips or proportions of trips, very small, sometimes probabilities of trips. So again, then those vehicular trips are passed on back to Metro, and I say that conceptually, these aren't coupled models, or we hand back the database to Metro, and then they do with it what they will. And we carry on those walk trips then into a destination choice component. So here, because we had 1.5 million PAZs, and the PAZs were quite small, we aggregated the PAZs to a super PAZ, so a 5x5 aggregation, to make the destination choice more tractable. Again, that was just somewhat of a arbitrary decision. It could have been a 7x7. We wanted to have at least one grid cell in the center, so we wanted an odd number by odd number. But we have the super PAZ structure then, 5x5, and we then want to distribute trips to the other super PAZs, and then have a third step where we then allocate them once we get them in the super PAZ back down to the PAZ level. So here, the destination choice model, we were using network distance, so centroid to centroid network distance, some measure of size, so what kind of activity density we would see on the destination end, some measures of the pedestrian environment. So here, we also added not just pi in terms of positive attributes, but we also added barriers. So the average slope between the PAZs, the number of freeway crossings or interruptions, and the amount of industrial land. We were hypothesizing that industrial land is probably correlated with environments that are less hospitable to walking. And then traveler characteristics again. Here we had 6 types of trip types. And so, again, only to show you that I think we have more work to do. We're really underestimating on average the distance walked, but in some cases we do better than others. So for work trips, home-based shopping performed quite well, but overall people are willing to walk more than we are modeling their distances walked. So there more effort needs to be put in refining this part of the model. So that's the overall framework in terms of thinking about how we might scale, incorporate the kind of built environment characteristics that pedestrians would care about, and you could have the policy sensitivity there with minimal changes. So this is a very practical exercise in many ways, but having gone through it now, we have lots of things that we want to work on for the next steps. So first of all, how do you forecast pi, and also how do you forecast, or how do you allocate your population and housing forecast down to this PAZ level? It's not an insignificant task, and Metro is still working on thinking that through, how they want to have it's a question that they're going to have for their activity-based model at some point, so I'm just waiting for them to solve that problem rather than solving it for them. But ultimately, they want us to take this work and move it into their activity-based model and their microsimulation framework. So in terms of the various tasks here, there's things that we want to do to improve it. So in terms of trip generation, we might think about having a multinomial logarit for trip generation instead of a regression coefficients. In terms of mode choice, we would like to have more feedback. So again, having better representations of costs and travel conditions along the routes. What's absent is really a good representation of the alternative modes, so we don't have measures of, say, regional accessibility or transit accessibility there. And then destination choice, lots of nonlinearities we want to think about, and other types of interactions between the built environment and the traveler. And then route choice or potential pathway. So one of the questions is when we end this work, we have basically the OD matrices for pedestrian trips. And so whether or not we need to actually think about assigning those trips onto a network, or we just think about mapping those places as potential for pedestrian activity and think about the spaces in between, if you were going to use this to do some pedestrian planning. It's interesting because if you are in a well-connected central area, you have lots of route choices, and people vary their route choices to go between regular destinations. So thinking about assignment maybe makes less sense there. And then if you're in a suburban context, you have few route choices to begin with, so it's that middle ground where you're seeing transitions from, say, the center city to the suburbs, so for inner ring suburbs. Okay, so some thinking here about opportunities and challenges we want to work on, both in terms of feeding pedestrian research, but also thinking about model development and data. So in terms of behavioral research, there's lots of reasons why we want to think about decision sequencing and whether that's different for people who want to walk versus taking other modes. So do you choose the activity first, then the mode, and then the destination, which is in the case what we've done in this model. Is it activity, destination, mode? This is a traditional sequence we think about. Or in many cases, it could be I've chosen the mode, I want to take a walk, and then I decide where I'm going to do, and then I decide what the destination is. So I think this is an area that's fruitful for more work. And then thinking about destination choice consideration. So how do people generate their choice set? Not just for pedestrian travel, but just in general, what are their considerations? And how do those considerations feed into this decision sequencing? So again, the choice set generation might be very different depending on how you've sequenced your travel behavior decision. The willingness to walk, so this is a tough question because if we're using a revealed preference data set, you only see how far they've walked. You don't know how far they would have walked or would have been willing to walk. And one of the odd things is the more amenable the environment is to walking, the further people are willing to walk, but they don't necessarily have to. So thinking through how we capture willingness to walk and what are the attributes that are important in routes and in coming up with those measures. And then path route choice considerations, there's been a fair amount of work happening at Portland State on this, and how to attribute the network and think about capturing those aspects to then feed back into other parts of the model. So feeding back into the mode choice, for example. So in terms of the built environment, so this is another area where my group is doing a lot of work. So thinking about thresholds and non-linearities in the built environment. For example, do we have a minimum density that we need to achieve to start to see and detect walking as a viable mode choice to begin with? And then sort of at the top end, if we just continue to increase density, will we see a higher walking rate? So we might see more walking, but do we necessarily see walking at a greater rate? My PhD student, Steve Gerke, has been doing a lot of work on how we capture and measure mix. So what are the right composition and configuration of the built environment? And this is, again, not just a question for pedestrian modeling, but I think when you're starting to talk at this fine-grained scale, it really makes a difference in terms of thinking about propensity to walk. And then what's the right scale to capture these built environment measures? So historically, we've used some sort of buffers that are half mile or quarter mile, but it may be that different attributes of the built environment have a larger or smaller effect in terms of its impact on behavior. So thinking about what the right scale is to measure these attributes, I think, is another question, and whether they all need to be measured at the same scale. We're interested in these lifestyle questions, so thinking about some of the things that Pat was talking about earlier, attitudes and motivations and values. So why are people motivated to walk? Are they interested in health? Are they doing it because they're a captive pedestrian or transit user? And then how does that feed into vehicle ownership decisions, their residential location decisions? In the US, there's a company that has come up with this measure called Walk Score, and it's being used in a lot of real estate advertising. So when people go to buy homes, Walk Score, it'll tell you how walkable that neighborhood is. I happen to live in pedestrian paradise. But whether or not that's a valid measure of walkability is another question, but it does show that people are more interested in thinking about walkability in their residential location choices. And then, again, building on what Pat was talking about, my other PhD student, Patrick Singleton, is doing his dissertation thinking about positive utility of travel. So what are some of the co-benefits? What are some of the positive attributes about walking? What are the aspects about it that are important? And then where do you start to see diminishing returns? So if you're walking for health, there's some limit to which you're fatigued and you're not getting a positive benefit. You might be getting a health benefit, but you're starting to care less about walking for health after a while. So how do we think about those limits, and how do we incorporate those into mode choice so that we have better representation of walking and cycling in these other modes? And then feeding some of this back to the other steps. And so in terms of trip generation, we've done some other work on trip generation at the establishment level. And so some things that we find, for example, are that the drive to grocery store relative to walk grocery store is a 1 to 1.6 ratio. So you go 1.6 times more frequently if you're walking to the grocery store. And so when we're limited by this one-day travel diary, we can't necessarily see this increased trip generation. So I think there's some interesting feedbacks that as soon as we start to leverage and take advantage of multi-day or continuous surveys, we can start to think about how this plays out over the long term. Okay, and then in terms of data and models, so what scale do these things need to operate in? So we've done some very, historically gotten by with doing some things at the TAZ level with average measures of density. Maybe that's fine for back of the envelope mode share estimations, but it really depends on what you need for your policy or research question. So again, if you're trying to link this with health data, for example, one day isn't going to be appropriate. If you're thinking about linking it to risk exposure, you might want to have a finer grain temporal resolution to the model where you're looking at peak hour, hourly loads on a network. We definitely need to have the ability to capture variation in the pedestrian built natural environment. So we know that walking and cycling vary across seasons, and they vary across days, and they vary across hours in the day. And similarly, the environment, whether it's amenable to walking, varies a lot by the spatial scale. The other question is, how accurate do we need the model to be in terms of spatial accuracy? So what is it that we're trying to get at? Is this a walkable place, or really trying to nail down pedestrians at a specific intersection to think about what their response would be to increase connectivity? And then, again, there's a fruitful area here for theory and behavior. So what does theory tell us about what the spatial scale should be for pedestrian behavior? So again, we've been spending a lot of time thinking about how we represent the built environment and what do we include. And so often these things are aggregated into an index because built environment variables all tend to be correlated with one another, so you can't put them individually into a model. But from a policy perspective, you want to disentangle that index at the end and say, well, what is the relationship to density versus connectivity? And so it's a bit of a problem. And I guess the question is, with a model, do you want to predict demand, and do you just need a proxy for that built environment, in which case an activity density might perform perfectly well, or do you really want to detect specific policy changes or specific levers and what impact they have on demand? This idea of land use mix, I think we're doing it wrong. So we don't really have, again, theory should be telling us, or we should be thinking about how to measure empirically mix in a way that would give us the outcomes that we expect to have. And so an equal mixing of land use, I don't know why we would think that that would result necessarily in a better walk mode share, for example. So what proportions of retail to residential or office to residential gets a higher ped mode share, or for that matter, any other attribute like VMT. And then more and more thinking about the temporal aspect and availability of land use. So not all things are available at all hours of the day. So again, if you're trying to get at a spatial or a temporal resolution that's more finite, then we need to have better land use data and thinking about operating hours. Joe Broach, who just finished his PhD at Portland, has been doing a lot of work on how we attribute the network and how we think about representing the built environment along the network. So again, it's not an insignificant task. So typically we've just come up with some aggregate zonal-based measure or some buffers around origins and destinations, but we really need to think about what's happening along the path so we can have better idea of travel costs and how we would feed that back into mode choice, for example. And then I think this other question about assigning trips to a network, it depends on whether you need that model output at that resolution or not. And then finally, a thing that we're working on is then linking this to health outcomes. So this is a conceptual model from James Woodcock and his co-authors, who is at Cambridge, and he's been looking at epidemiology studies and thinking about health impacts. And so here he wants travel times, but they want aggregate amounts of travel time, and they want to know travel speeds because they want to know how vigorously you're getting your cardiovascular workout. And so again, that's something that might be easier with cycling because there's much more variation in travel speeds, but walking, it gets harder and harder to detect. He's also working on crass risk exposure, pollutant exposure for respiratory illness, and then as Rolf mentioned yesterday, how that could feed back into life cycle expectancy. So it starts to get a little squirrely or dodgy when you start to think about those probabilities and how far you're stretching them, but I think it's a great addition to what we're doing about how we can have better assessment of the health impacts of various scenarios. So I think I'll stop there.
Thank you, Kelly. This was great. So the reason why I invited Kelly, not only because I highly respect the work she's doing, but also I was realizing that in our land use transport models, we mostly ignore walk trips, even though in Germany it's a quarter of all trips. So I felt this is a topic that's also relevant to discuss here.
I was just wondering, which attributes do you want to include in the detailed coding of the pedestrian networks? Because it becomes very involved if you want to do this right. And then the second question is, at that small level of detail, I believe, again, we have to get a much better understanding of the destinations as such, because people don't walk to a zone, they walk to a particular cafe, they walk to a particular store, so we need a much better understanding of those destinations. What are your ideas on that front? How do we capture those differences?
Yeah, so at least in terms of destination choice, I think it's just a fundamental travel behavior study and not so much thinking about the model itself. So it's going to require some focus groups, some surveys in terms of thinking about how do people choose a destination. So again, in unrelated work, we've been doing a lot of intercept surveys as part of like ITE trip generation, and there's an opportunity to ask people questions about why they chose that destination. We ask how much they've spent there, for example. So you get a much better idea of what went into that choice. So, you know, it gets complicated because in the way that we've structured it, they've already made the decision to walk. But when you start thinking about the competing modes and how those destinations would work, I think it's very different criteria. And then in terms of attribution along the route, again, Joe Broach has done just the traditional measures, but the question, I think, which would be similar to the ones that we had in PI, for example. So is there a sidewalk? What's the traffic volume? What are the densities and so on? But, you know, I know you've done some work here where you start to think about, well, buffers along the route, but how far and what extent does that matter, particularly when you're headed to a specific destination?
I think that question was really more informed by the work we did in Singapore, where we tried to characterize the sidewalks in great detail. We looked at shading, we looked at weather protection, we looked at the amount of windows, we looked about the greenery. We looked, but not as much detail, on the quality of the surface itself, which in many cities can be absolutely horrible. You wouldn't want to walk there, and so on. Is that what you think should be done?
No. Well, I don't. If it is, I don't want to do it. So when I was at Maryland, I did one of these pedestrian audits, and we went out and, by we, I mean my students went out and audited all of College Park, Maryland, and that was when I just said, you know, never again, we're not going to do this. So,
but it's interesting. We see actually, we estimated some choice models, clearly relatively small sample and relatively short walks, but it clearly has an impact. It makes a difference.
Yeah, it does, as does all of the crossing treatments and so on.
Yeah.
So I would say, yes, it's important, but we're not there yet in terms of the data archive, and I don't think we're there yet in terms of handling it and modeling. So maybe if you're doing a very constrained microsimulation where you are putting pedestrians on the network, it makes more sense. But to think about it in a larger urban space, I think it would be a function of finding proxies for those attributes. And then I guess the question is, you know, if you want that to feed back into your mode choice or your destination choice and have it represent a travel cost, you know, how much do you need to sort of get an adequate representation of travel cost versus picking specific routes for travel and assigning people to a network?
I think the context in which we did this was for the URA, the Urban Redevelopment Authority in Singapore, and we developed essentially a GIS tool which showed them the catchment area of a given building given the walkability of the environment. So we can show that for them it's worthwhile investing, let's say, in an underpass instead of an overpass, investing and some treatments to essentially make particular lots more attractive. And because the URA actually earns money by selling property and land, it's actually something which is worthwhile for them to know. So, but this is clearly micro level
Yeah, and I think if one were to use this for corridor study, I think then it becomes much more important. But, you know, the decisions, the infrastructure decisions here are not going to be whether to build an overpass or underpass. It's really how densely do we want this area or neighborhood to be, and what kind of, you know, are we putting in basic infrastructure? But yes, absolutely, and I've sort of stayed away from it just because it's wildly labor intensive and nobody wants to pay for it. Is it free? It's not free for me.
Kelly, I was stunned by the number that you said, that people who do walking for shopping trips do 1.6 times as many trips,
Yeah.
as many shopping trips.
Not in a day, of course, but
On the average, right?
on over the course of a month, yeah.
But 1.6 times as many trips, is that what you said?
Well, for grocery shopping trips.
Yeah, which really means that's screws up our transportation models, because I don't know of a single transportation model that takes into account trip frequency when they do mode choice. Neither trip-based nor activity-based models do that.
Yeah, and as long as you're modeling one day, it becomes more complicated. But I mean, whether you're going to make more shopping trips in that particular day, I don't know how you would incorporate it. But we know that there's this difference, and so when we start to think about mode shifts, so if people are going to not drive and start walking or taking transit, you know, you're probably not going to go to work more. So that could be a one-to-one mode substitution. But for some kinds of trips, there's a frequency implication for and a time, activity time relationship as well. So how long your duration of activity. And I think that's sort of an unrelated point, thinking about these co-benefits and thinking about sort of exercise budget. So if you're motivated to walk for health reasons, you know, how much walking are you willing to do and devote in terms of your day? So on one hand, there's an efficiency. So if you're walking for exercise, maybe you're not going to the gym or you're not doing some other kind of walk, but it is taking a significant time out of your day. So what is the time consumption commitment someone's willing to make?
If you walk for your Fitband, then
Yeah.
right.
So it's more of a remark than a question. So it's a very well-hidden fact that there's a guy called Michael Bruce, who's based at the University of Mainz in Germany, who's done some quite interesting work linking a simplified dynamic model of thermal comfort with an agent-based model of pedestrian route choices. So he represents agents within a cellular landscape. They have an origin, they have a destination, and he calculates the route that they choose based on neighborhood operations, where movement to the adjacent cell is given a distance penalty if it's uncomfortable. So they'll end up choosing, you know, a route which is some kind of compromise between minimizing their distance but maximizing their comfort, and it's, you know, somehow a useful tool for studying relatively severe sort of climates and, you know, finding a good compromise. It might be something worth.
Yeah, I mean, I think, you know, in Portland it rains a lot, so I'm waiting for them to institute an awning regulation as part of our development code, so you can walk without getting wet. But it's a factor that's, you know, how far are you willing to walk or bike in the rain, and then of course that relationship is sort of regionally, culturally. Your tolerance is based on where you are. So, you know, if I was looking at some of these relationships between weather and walking in Australia, where, you know, the variation in temperature wasn't so great, but you still saw variations in walking. Where, you know, if you go to Minnesota, where it's very cold in the winter, you still see a significant bike mode share there. I mean, they're crazy there, but so how you then, you know, transfer that model somewhere else, or those ideas, I mean, it's a really important question, but it's sort of similar to Kai's point, like at sort of the urban scale, it becomes difficult to operationalize.
Kelly, great. I mean, spend all afternoon talking about the issues you raised. I mean, we've been starting to do more both walk and bike modeling. Nowhere near what you or Kai have been getting into, but a lot of what you said resonated. I mean, I think this issue of mode first versus destination versus, you know, how many you do. I mean, I think actually for walking in particular, that's a very complicated interrelationship. I'm a walker. I walk to work. I walk about 5 miles a day, and that certainly changes my shopping. I don't do a lot of shopping, but because I'm walking, I will be looking for opportunities to do a shopping trip. And so,
Right.
so there, and you know, in my case, that's a walk commute. So there is a decision to walk, but then that certainly is influencing destination choices. But within that, I might actually have a sub-mode destination choice. Let's say I need to pick up a bottle of scotch, and you know, can I pick that up walking, or do I have to take transit? So I think from an activity modeling point of view, I think taking walking in particularly seriously is a very interesting challenge. The other thing, I mean, in our little bit of work, convinced is too strong a word, but our working hypothesis is we think we need route choice for both bicycles and pedestrians. And the analogy is, you know, directly to cars and transit. I mean, we don't even think about it, but we do assignments and we skim networks to get the path attributes that then go into mode choice. And I'm not sure we're going to be able to explain bicycle or pedestrian mode choices until we have sort of, you know, the equivalent skims. But I think the route choice is a big problem, particularly for pedestrians, because I think certainly in grid networks there's a lot of randomness. The light turns red, and so you turn right, you know, instead of waiting. So I do think there's a lot to be done there. These are all sort of comments, I guess, rather than questions. But I was intrigued by your you know, talking about that we're not getting kind of mixed neighborhood effects right, and I think I would agree with that. I mean, we've tried just simple-minded entropy measures, and they don't work. You know, it's at least in our experience. Okay, so I probably rambled on enough, so I'll stop there. Is what I'm going to do.
Well, Joe Broach, who did his dissertation looking at pedestrian and bicycle route choices, did a route choice model for Metro, and it is included in their travel model. So, you know, it's interesting that Oregon has advanced their bike model portion faster than their ped model. I think for most cities it would be the other way around, but. We also, in the destination choice, or just to build on your first comment, you know, we were sitting around saying, well, why would size attributes matter if you were doing destination choice? So if you already knew you were going to a restaurant, why would having more restaurants, you know, it depends again on how people make these decisions. And so, you know, we kind of got to this idea that, well, we're only doing a trip-based model, but if you were doing a tour-based model, of course, then you could capture secondary trips along the way or efficiencies there. So I think, you know, there's no shortage of work to be done on the travel behavior side that can inform how we think about structuring the models.
I was just going to ask a question following on from Eric's comment, I think, about whether the analysis that you're undertaking assumes that the conventional view that the transport is a derived demand from the need to get to a destination. To what extent people, particularly the retired population, other non-working people, or those caring for small children, may be choosing a destination as as part of the process of simply going out for a walk,
Right.
you know, for fresh air, exercise as such, and you know, whether that may confuse some of the analysis, because it's not that people, maybe not be that people are more likely to walk to a destination if there is a relatively attractive environment for getting there, but they're going that way because there is an attractive walking environment, and they just happen to stop and do something at the apparent destination before coming back again. But
Yeah, I can't
there's a
tell you how-
possibility also that there's a complete loss of the health benefits here if people go out for a walk but then take a Starbucks latte before coming back again. That probably undoes all the good. But
Yeah, I go for walks all the time and then end up at the bar, you know, on the way. So,
That makes me feel better, thank you.
Yeah, I mean, I think it's a problem in thinking this through. The one thing that I will say is we did separate out recreational walk trips, but that's where they were identifying that as their primary purpose. So I think one thing is, when you think about the travel surveys, is having better questions about purpose versus destination. And again, thinking about multitasking, you know, sort of multi-purpose or multi-goal, multi-motivation trips. So if we understood more about that, I think we could get at some of the destination choice, but also the sequencing, the decision sequencing. But when we separated out the recreational trips, you know, all of the traditional built environment measures were less significant. So parks were more significant. We had parks in our measure of PI, but that caused problems for the utilitarian travel trips because one, just thinking about parks as a land use and how you represent that, and we have several very large urban parks in Portland that don't have accessibility. You can go hike for 30 miles on a trail in Portland, but you're not going to do that for utilitarian transportation. So we took that out of PI, but thinking about specifically for recreation trips, and then not all recreation trips are created equal. So some people are walking the dog or going for a stroll after dinner versus going to a park, a specific destination for recreation. So all of it's your points are well taken.
I remembered the other two things I was going to say. Again, you talked about positive utility of time, and again, I think this is a generic issue in activity-based modeling. Is I think we have a real problem differentiating between the time, the utility we get from spending time on something versus the expenditure, the benefit versus the cost, and it's confounded in time. And so I think, again, for walking, again, I walk because I get positive utility from it, but there's also a cost associated with that. I'm not at work, I'm not at home, so I think this applies to all modes of travel. So I think, it ties into obviously the stuff Pat talks about, but I think we need to disentangle that better. But also coming back to this mode, destination, route choice, I mean, in our pedestrian modeling, which is fairly simple, but we're actually seeming to get, at least with our little data set, pretty good fitting models with actually a fairly parsimonious set of variables and not a lot of the things we talk about here. And we're wondering whether, in fact, the things we talk about, whether it's walk score or whatever, actually may have more to do with mode and destination, maybe even generation, than the route choice itself, that possibly the route choice is a little more utilitarian. So how much are we deviating our route? Because certainly as a walker, I'm very interested in the shortest path most of the time. So how much will people deviate from the shortest path given the effort it takes to walk, to be walking on a nicer street? I think people do that. But maybe the fact that you're walking at all is because it's there's good destinations there. So I think it's much more of a joint, coming back to my earlier comments, I think it may well be a more joint problem than we often give it credit for. We're still in sort of the four-step model view of the world, and maybe we need a more integrated look at that.
Yeah, and Joe Broach has looked at this question in his dissertation. So he had GPS data, and I think this is, as we start to think about more passive data collection, we can answer some of these route choice questions more readily. But he had GPS data for bike and walk trips, and then looked at the deviation from the shortest path and the attributes. And so being able to then place a value, a positive value on, or a discount based on what the attributes were on the shortest path versus on the path taken.
So
my current work is to take the detailed measure of PI and see how far we can just abstract it to a general measure of walking and get the same reliable estimates, because while Portland has great data at a great resolution, Omaha, Nebraska perhaps doesn't. So
I was just wondering whether you've considered time of day and perceptions of safety. So in the nighttime, there is there are fewer alternative modes of transport available. Also at nighttime, there is an increased perception of that walking may be unsafe. So anecdotally, talking to some of our female students at the University of Nottingham, then there are some particular routes through the city that they would very much avoid, because they perceive that there's a lot of drunkenness, that they may be they may be assaulted, or even if they're not assaulted, it's simply not a comfortable experience for them. So they'll take a considerable detour, or avoid particular parts of the city completely. Just wondering whether that's cropped up.
So Metro's model isn't sensitive to it's just peak hours and off-peak hours. So we really didn't have that kind of sensitivity, but it's a completely valid point. And then the other thing is the data we've been using so far is our Oregon Household Activity Survey. So we actually don't have any route information in there. So we only know origins and destinations. So that's also why I've been dodging the route question. So we would need GPS data, but it's a completely valid point. And then thinking about all of these audits, when we do collect this information about the route, we're often collecting that during the daytime. And so being able to measure, lighting and, how well lit is an area, or how active is that area in terms of street or storefronts and those kinds of things, it would change the ambiance and give a sense of safety. So we didn't have any information about crime and perceptions of crime or feelings of personal security, but we know that that's important. It's also a difficult thing, similar to what Pat was talking about how you sort of attribute that to households and how you think about forecasting or changing that.
Need to continue this discussion in the break, but it's fascinating. Thank you very much, Kelly.